We're going to find the critical value for a given confidence level. Let's look at finding the critical value for z alpha over 2 equals 82%. What this tells us is we're 82% certain of our results. Now I understand that's a little bit low, but it works for the purposes of demonstrating this example. Before we can use a reference table to find the critical value, we need to find the alpha level. Now recall the alpha level is how uncertain we are. In this case, we are 18% uncertain in our results because we're 82% certain. The two must add up to 100. So I'll subtract the percentage given from 100 to find my alpha level, or 18%. Now the given information in this problem says that this is a two-tailed test because we have alpha over 2. So we'll divide this by 2 to give our lower and our upper tails. Now from here there's two ways you can look at the problem. I'm going to take a look at 9% and turn that into a decimal, 0.09. This is what I'm going to use to look at my reference table. Now, when we look at a reference table, you're looking to use a standard normal table. There's two tails to this test. There's the lower tail, in this case the 0.09, and some people prefer to look for the upper tail as well. And they say, okay, well I'm going to look for the upper tail value of 0.91, again realizing they must add up to 1 or 100%. Either way is fine. I'm going to look for the 0.09 on the reference table, and then I'm going to recall that critical values are typically given in their positive form. When using a reference table, you want to use a standard normal table. This is available to you in the back of your textbook, or a simple web search of standard normal table will bring up several possibilities. Now looking for the value of 0.09, I'm going to look for the closest value on this table. Looking at all these values in here, I'm not going to find it exactly, but I found 0.0901. Pretty dang close. Negative 1.3 is the row, and that corresponds to a column of 4, giving me a critical value of negative 1.34. If you were looking at the other tail or the upper tail, the 0.91, what you would notice is looking for 0.91 on the table. Let's see how close I can get. 0.0999 would round to 0.91, and that provides the critical value of 1.34. They're identical with the exception of the sign. So in this case, our critical value is 1.34. If you chose to look at the negative or the negative 1.34, just recall when we provide the critical values, we provide the positive value, so just turn it positive. Now you have the critical value associated with your z value.